Hello everyone, and welcome to our next video, and our next video is on electromagnetic energy. So electromagnetic energy refers to energy like light, visible light. So the light you're seeing here coming from a rainbow, red, orange, yellow, green, blue, violet. All right, these are actually, they combine together to make white light. Okay, but what you're seeing there is the color is refracted because what happens, the sunlight travels or passes through water droplets during a sun shower. It will spread out and you'll see Roy G. Biv, right? The colors of the rainbow. So all the colors together make white light, and there they are separated, all right? So electromagnetic waves are waves that do not require a medium to travel. Okay, so light, microwaves, radio waves are all examples of electromagnetic energy. They travel rather quickly. They travel at the speed of light, which is 3 times 10 to the 9 meters per second. Put that in perspective. So here is a meter stick. So 3 billion of these every second, right? So that's pretty rapid. Okay, much faster than speed of sound, which is only 340 meters per second. I mean, sound is pretty fast, okay, but light is way faster. Okay, electromagnetic spectrum is the range of electromagnetic waves with different frequencies, different wavelengths. Okay, that's how we compare them. So radio waves, microwaves, infrared, visible, UV rays, X-rays, gamma rays are all examples. Energy is radiated out of all objects above a special temperature called absolute zero, which is negative 273 degrees Celsius. So that's basically the temperature at which molecules stop moving altogether. Right? So even in a solid material, we mentioned that the material wiggles in place to give off its energy. Well, absolute zero, that object wouldn't even wiggle. Okay, so that's a theoretical temperature. It's not a real temperature because we haven't measured anything at that temperature exactly. We have things that approach that temperature but never reach it. Okay, and we made a scientific scale called Kelvin. So 0 Kelvin is the scientific scale in which absolute zero is based on. And if you get to chemistry, we'll definitely talk about that in chemistry. All right, so here's electromagnetic spectrum. One side is long wavelength. You can see the spread out waves, low frequency. The other side is short wavelength and high frequency. Okay, so the ones on the right are more dangerous potentially than the ones on the left. All right, I'll discuss that in a moment. So gamma rays are used to destroy cancer cells and diagnose the disease. That's radiation treatments, as you guys know them. Also, gamma rays are given off during nuclear reactions. They do come out of the sun occasionally and head towards the Earth. They can disrupt our communications here on Earth, the gamma ray bursts. Okay, very short wavelength, high frequency wave, right? Very small wave. X-rays, another small wave. This penetrates through soft materials. It's used to examine bones and teeth in our body. However, when you do get an X-ray, you guys know you wear that big heavy lead suit over the top of you. That's to limit the amount of X-rays going through your body. Right. Also, the X-ray tech leaves the room. That's on purpose because they don't want to get X-rays all day when they're taking the X-rays. Right, because we know that any high frequency sort of radiation may lead to cancer. Right, and that's the funny thing about gamma rays. They're also used to destroy cancer cells. However, you're giving more radiation to your body. All right, so you got to be careful with both these forms of energy. X-rays, you want to try to limit them. When you're younger, obviously, teeth, they got to keep taking pictures of them and make sure they're coming in right. But as you get older, you might take less and less of them to kind of help yourselves out. All right, ultraviolet. This is emitted from the sun, can cause skin cancer, used to kill bacteria. I do actually have a goggle cabinet over here in the classroom. that has ultraviolet light in it. So I turn that on before each student uses it for about 15 minutes, and that sterilizes the goggles. All right, visible light is the only electromagnetic wave we can see, composed of Roy G. Biv, red, orange, yellow, green, blue, violet. We leave indigo out because that's very close to violet. But either way, that's visible light. Okay, infrared is detected in the form of heat. So body heat is infrared. So any heat that comes off an object is infrared. Microwaves are used to heat up food. So also used for communication a long time ago. We stopped using it for that though because we found out radio waves are a little more effective at that. So radio waves, energy is converted into sound, picture, wireless devices, radar. It's the longest wavelength, shortest frequency, right? So not as dangerous as some of the other energy forms. However, long-term exposure to them, that's one thing we're trying to look at. Can they be harmful over a long period of time? Okay, what else can happen to electromagnetic waves as it travels? They can be reflected. So some cases, like the lead suit, when you're taking an x-ray, you want to reflect them. You don't want to take them into your body, all of them. Absorbed, it means taken in. So infrared heat energy can be absorbed by our body and we warm up. Transmitted means to pass through. Windows allow sunlight to come through. So that's an example of transmitting energy through a material. All right, and that's it for electromagnetic energy. Thank you guys for tuning in.